All right, so we're going to take a look at problem number 6 on the practice test, another problem that involves translations, rotations, reflections. So the problem says in the coordinate plane shown, triangle ABC is congruent to triangle A prime, B prime, C prime. And triangle A prime, B prime, C prime is similar to triangle A double prime, B double prime, and C double prime. So that's the given. And in part A, it says describe a single transformation that shows that triangle A prime, B prime, C prime is congruent to triangle ABC. Include all the necessary information to complete the transformation. All right. So looking at this, they want to prove that it is congruent. And you'll remember that congruent means the same. Same size, same shape, same angles, same everything. And so we want a translation that will do that. And what I'm doing is I'm looking at point C and point C prime. And I notice that point C and point C prime are 2 spaces apart. Well, what's half of 2? You're going to tell me 1, right? So I'm going to take a look at this line right here. And it's helpful if I use a pen. This line right here. And I notice that this point is 1 point away and 1 point away. So if I reflect over a line x equals 1, so the line here is x equals 1, let's see if I get the same thing. And so I already know that point C and point C are equidistant from my line of reflection. And let's see about my other points. Point A is 1, 2, 3, 4 spaces away. And it's 1, 2, 3, 4 spaces away. So that's, again, equidistance from the line. And then point B and B prime are also both 4 spaces away. So we know that the reflection over line x equals 1 would give me a congruent triangle. Okay. So then it says describe a single transformation that shows that triangle A prime, B prime, C prime is congruent to triangle ABC. Include all the necessary information to complete the translation. So the shortest answer is ABC, and that's triangle ABC. Can be reflected over line x equals 1.
So what is the fact thing?
And I know that it gives me a congruent shape because if I perform this reflection, point A and A prime are equidistant. To the line of reflection. And then I could go on and say the same for B and B prime, C and C prime. And that would be enough to describe how I know that this translation would give me a congruent shape. Now, I'm guessing that it's too much to hope for this problem just being done with that one. Done with that. Oh my goodness, come on. Don't you hate it when the computer's not working right? Okay. All right. So then, if I scroll down, oh, that is all I have to do. Great, so I'm done. And it doesn't even talk about the double prime triangle. But, oh, I do. Part B. Describe a sequence of transformations. A sequence, so that's more than one, of transformations that shows that triangle A prime, B prime, C prime is similar to A prime, B prime, C prime. So we're going from the single primes to the double primes. So let's go back up to my drawing. And so we are going from this triangle to this triangle. We're done with the original. Well, what I can do is, let's look if I can, it looks like I have another reflection going on because I know that this part and this part, I mean A and A prime, they're on opposite sides of the triangle. One's at the bottom, one's below. So I notice that this is 1, 2, 3, 4, 5, 6 spaces away. It's 6 spaces away. That means that if I reflect over the x-axis, this point is equidistant to this point. Okay, that's a good start. B is equidistant to B here, and A is equidistant to A over here. So I know that first, a reflection over the x-axis would position my triangle just about right. So once I do that, I notice that my triangle, and I'll go ahead and draw my triangle here. So I can see right now that I have my A prime, B prime, C prime overlapping a portion of my A double prime, B double prime, C double prime. And so I'm wondering if it asks for me to make the exact same triangle, or if it's enough to just prove they're similar. So I'm going to reread it. Describe a sequence of transformations that shows the triangle A double prime, the double prime, is similar to A prime, B prime, C prime. Include all necessary. Okay. So then, similarity. What makes things similar? Well, I know that if two shapes have the same angles, they are similar. So at this point, what I could do, although I don't know if it's the best idea, but what I could do is say, all right, I know that angle, and I would have to talk about my transformation, my reflection over the x-axis, but I could say that angle A prime, C prime, B prime is congruent, the measure equals the measure of angle A double prime, C double prime, B double prime, simply because you can see that they overlap exactly, right? And we have a side length here that's 2, 2, so it matches up perfectly. Then I could also say that angle, the measurement of angle C, so I'm still calling this C prime, B prime, A prime, that the measure of angle C prime, B prime, A prime is equal to the measure of angle C double prime, B double prime, A double prime, because we have a right angle and a right angle. So then, if I have two angles that are equal in a triangle, then I know the third angle is also equal. So I could say that I can see that the triangles have the exact same angles, so I'd have to write that. I could also say that the side lengths are all doubled, right? So if I take my triangle, well, let me move it. If I take my triangle, trying to get it to move. So, and put it here, that's a scale factor of 2. I'm looking at the shortest side. It's another scale factor of 2. And then I can talk about the hypotenuse also. anything twice as long. So I know that I have a dilation, which is another translation, at point 0, -3, where I am multiplying the side lengths by 2. So I have a dilation factor of 2, and from this point, I'm multiplying these points by 2, starting from that point. And dilations will start from a point, and points will move only along a line starting at that point. So there's that one. That was a long-winded explanation for one problem. Sorry that you had to listen to that so long. So then let's go to the next problem. All right, I've already done this problem, so I'm going to include it in a separate video. So number 8. Martin is considering the expression, that's a nasty expression, 1/2 x squared plus 48, and the expression, this is even worse, the opposite of the quantity, 1/2 x minus 3, plus 4 times the quantity, x plus 5. And he wants to know if one expression is greater than the other for all values of x. The easiest thing for me to do here, is to read the question. So for part A, it says, which statement about the relationship between the expressions is true? It says the value are always equal. Okay, so essentially it's saying they're always equal, sometimes equal, and which one's greater and which one's smaller. So the easiest thing for me to do is to actually simplify both expressions as far as they can go. And that will show my answer anyway, so that's what I need to do. So if I have 1/2 times 7x plus 48, I would multiply this out. 1/2 times 7x is 3.5x. 1/2 times 48 is 24. And so my other expression, I'll use a different color, my other expression is negative times the quantity, 1/2 x minus 3 plus 4 times x plus 5. So let's multiply this out. And with this negative sign here, I have to distribute that negative sign. So we have negative 1/2 x. A negative times a negative is a positive. 4 times x is 4x. 4 times 5 is 20. So let's combine my similar terms. I see that these two are similar. So I know that negative 1/2 x plus 4x is going to be 3.5x, 3.5x. That 3 plus 20 is 23. So here's the thing. Are these two things equal? And the answer is unequivocally no, they're not equal. So moving over here, it says the value of the expression, the short one, is always equal. So I can automatically cross this one out because it's not always equal. Then for my next one, it says the value of the shorter expression is always less than the other one. And we know that's not going to be true, because if x is 0, this expression is going to be 1 more than this expression. So I know this is true. Not true. Then it says the value of the shorter expression is always greater. Now, I could see you choosing this one, but it's not C. It's not C, because what happens? Oh, never mind. Well, if this is negative, it would always be greater than 1. Yeah, so yeah, this one would be the correct answer, because 24 is always going to be bigger than 23, and there's nothing you can do about it. And there you have it. And then the value is sometimes greater, sometimes less. This one would work out if the x values, if these numbers here were not the same, because then you have the issue of if you multiplied by a negative or not. But since they're the same, they kind of cancel each other out, and you're always left with that 24 versus the 23. So the answer is C. And the way to show that is to show your math work here. Last one. Oh, I'm hitting the wrong button. Wish my transitions were a little faster in this, but I'm sorry. All right, gasoline mileage for two cars can be compared by finding the distance each car traveled and the amount of gasoline used. The table shows the distance that car M traveled using X gallons of gas. The graph shows the distance that car P traveled on X. So of course they give you a table and a graph and they tell you which one's better, right? So based on the information in the table and the graph, compare the approximate miles per gallon. Okay. So essentially the miles per gallon, miles per gallon, we need to find the slope of these, don't we? And if I look at the graph, I notice that the points aren't lining up exactly. But, and I have a handy dandy ruler here, right? So I'm going to bring it down here, and I'm going to rotate it. Okay, so it rotates about its middle point. So, no, that's not quite right. So rotate a little bit more. And so, don't touch the mouse. Does that look about right? Well, most of the dots are a little bit higher than that, so I'm going to, don't touch the mouse. Can you two please get away from my computer because you're making life hard. Alright, so if I look at this line, that's going to be about right. So I'm going to draw a line that's close. Alright, and so, you know what I would do? I would just use, since this dot is on my line of best fit, and that's what we're talking about, line of best fit, I would just go ahead and make a slope out of this. And so I have 5 gallons, and in 5 gallons I want 160 miles, so let's find my miles per gallon. I'm going to divide, right? So 160 divided by 5 is equal to 32 gallons. Well, the same thing's going to have to happen here. I need to find the difference. The difference here is 30.1. The difference here, and the difference here is 1, so the difference here is going to be 100, 100.8. I'm just going to round that to 100, folks. And that's 4. And so divide 100 by 4, and I get approximately 25 miles per gallon. And then from here to here, get off the you have to back off because you keep hitting the mouse and then my board keeps moving. And then of course they put 5 here. That's kind of obnoxious, right? But let's just deal with it. Let's find the difference between these two. And I'm allowed to use my calculator, so I will pull up my calculator. Alright, and so if I go 137.5 minus my 80.5, I get 57. So that's 57. And from 3 to 5 is the difference of 2. So if I divide this by 2, I'm going to get something that is less than 30 again, aren't I? Yeah, I'm going to get 28.5. So looking at my slope for my graph and my slope for my table, I can see that all of these are below 30. This one has an overall miles per gallon of roughly 32. I think it's fair to say that car P gets a better gas mileage by, I would say by a good 4.5 miles per gallon, which is significant. So when it says enter your show your work or explain your answer, here's what you're going to have to do. You're going to have to go through discuss how you found the slope for p, which means finding the rise over run on the graph. And then for the car, you're going to have to talk about finding multiple slopes, again, the rise versus the run, so that you can then type in, you know, if you use the median, that's great, that's fine. You could say the median of this data set is, you know, 30. Obviously, we didn't try all the combinations, but we'll just go with it. If you can say you found the slope between 3 points and the median of them was 30.1, therefore you're willing to say that 32 is greater than 30.1. And that's about all that you need to do on that problem.